Jai Jinendra, Namaste, welcome to my channel. Today we are going to solve the 23rd question of the problem solving series, which is based on arrays. And this is a very popular question, trapping rainwater. And this has been asked in Amazon, Google, Microsoft and multiple companies. The difficulty level of this question is hard. So let's begin. So we are given an array of non-negative integers, and this is represented by an elevation map. So where each bar's width is 1. So here in this example, the array contains the elements as the first element is 3, then 0, then 2, then 0, then 4. So this is represented over here in this way. So this bar has there are 3 bars here. So the length is 3 and then no bar 0, then 2, then 0, then 4. Okay, we need to find how much water this array, this bar can contain, this whole structure can contain whenever there is rain. So how much water, how much rain can it trap? So in this example, if you see, so here, so for example, if rain falls over here like this, right? So here, this representation, this part of the index, this index cannot trap any water, because if water will come here and it will fall either here or here. So water cannot be trapped over here. Where water can be trapped? Here water can be trapped. How much water this can trap? Suppose the water falls over here, this much it can trap, then this much it can trap. If it crosses this, can it trap this one? If it goes beyond this part, then here it will come over here, right? So even if it comes over here, you can see that if I draw a line like this, since this length is 4, right? So it can actually contain this much, because if it crosses this length, then it will fall over here. But if it crosses this length, it won't fall, because this itself can contain this much water and this can contain this much water. If this goes beyond this, then here it will fall in this side. So we can see the water it can trap is actually the minimum value that is present in its left part and its right part. The minimum of that is the size of is the height that it can take. Now it already has, for example, this one. There are already 2 bars, so it can only take one bar value, right? Here there are no, here the index value is 0, so it can take a height of 3, right? 1, 1, 1. Here it can take 1, and here also the value is 0, so it can take 1, 1, 1. So in this way you can see 1, 2, 3, 4, 5, 6, 7. It can this structure can contain 7 quantity of water, right? So let's solve this example. How much water this can contain? Similarly, what we will do, we will just draw this structure like this part, then it goes like this, and then it cannot go like this because it will fall. It goes like this, okay, and it can't go like this, it will fall like this, right? So here one value it can contain, here it can't contain, it will fall over here. Here it can contain 1, and then here it can contain this 1 and 1, here it contain 1, and here it can contain 1, right? So how much total values are there? 1, 2, 3, 4, 5, 6. So the answer is 6. So what do we observe? How do we solve this problem? How can we find the solution for this? We can see for any index, we have to find the leftmost highest value. So if we come to this index 2, okay, so here in this index, second index, whose value is 2, it can store 1 quantity of water. How did we find it? How can we calculate it? So what we have done practically, we have moved to the left part and we have found the highest height in the leftmost part for this. So we can see here the height for this 2 is 0. Here it is 3. So this 3 building is there. So it can contain to the left 3. If it is more than 3, then it will fall. Right. Now we go to the right part of this. What is the highest height in the right part? So here we can see the in the right, the next index is 0 and the next index is 4. So the highest is 4. Now, so it could have contained the 4. It could have gone to this part, right? But if you would have increased its height from 3 to 4, then the water would have fallen in the left part, right? Of course. So what we have done? So for at any index, what we have done, how much water it can store? The minimum of the leftmost highest value and the rightmost highest value minus its actual value, right? That we have done. Here the minimum of the left part was 4, 3, the right part was 4, minimum of 3 and 4 is 3 and the array's value is 2. So 3 minus 2 is 1. So here we have found 1. So the total value was 6. So for every index, we will find the leftmost highest, rightmost highest, get the minimum of that and then subtract it with its own value. In that way, we will get the value, right? So we can do it for the whole array and we will sum up the values and we will get our answer. So is it an optimal solution? How much, what would be the time complexity? So first we will traverse the whole array, that is order of n. While traversing, we will find the leftmost part. So for leftmost part, to find the leftmost part, we have, so for here the leftmost part, only one value we have to go. But for this one, we have to see all the left values. So in the worst case, the leftmost, finding the leftmost and the rightmost. For rightmost also, for finding its rightmost, we have to traverse the whole thing. So because for this one, the rightmost is 4, the highest value, right? So we have to keep on traversing. From here it should be less. When we are here, there only one value, but here more values, right? So finding the leftmost and the rightmost while we are traversing the array. So finding the leftmost is order of n, leftmost and rightmost is order of n, and multiplied by traversing the array. So the time complexity for this solution would be order of n square, which is not optimal, of course. This is the brute force solution. So what would be the optimal solution? How can we solve this optimally in a better way? Can it be solved in an order of n complexity? What have we done? We are finding the leftmost part and the rightmost part. So already the left value and the right value is fixed. We are finding it every time we are going here, doing it, repeating the same thing. For example, here when we are in 2, to find the leftmost part, we are going to 3, we are going to 0 and we are checking what is the max. Again, when we go to 0, we are going to 3, 0, 2, 0. Why do we need to do this if we already get the leftmost part computed before? Can we do it? Yes, we can have a leftmost array. We can have an array and we can store the highest leftmost values. We'll take another array, we'll store the highest rightmost value. Now we already have the leftmost value and the rightmost value computed. Now we will just use that value for this, for all the index. And then we will find it in one traversal and we'll have our value, right? In that way, we can solve it in order of n. So let me code it. Once I code it, then we will run it through this example, then it will be very clear. So what have I said? That we have this array, the size is given as n. So we will take a left array, we will take a right array, right? Now, obviously for the first index, the value would be, there will be no leftmost value, right? So for left it would be 0. For right, the rightmost value, for the rightmost, the right value would be 0. There is no water there, right? So this would be 0. Fine. Now we will be traversing the array from I equal to 1 to n minus 1. What would be the left value? The left of I would be a max of left of I minus 1 and the current value, right? Array of I. So here, when we go here, so left I minus 1, 3, and then it's 0 current value. So the left 1 will be 3, right? So for this one, what is the maximum? We will see, we'll keep on finding, right? uh, leftmost plus, okay, array of I minus 1 and left, right? So that would be the left I. Yes, so for this one, again, the leftmost would be this one and this one. It can't be done that way. So we will be taking the leftmost value as, not left I minus 1 and this, we will take it as left of I minus 1. Yeah, left of I minus 1 would be obviously the maximum one, right? So for this one, left of I minus 1 is 3, okay? Because we have stored that. Yeah, that is correct. So for example here, when we are over here, so when we want to find the max value, so what is the left I minus 1 value? It's not 0, it's actually 3, which we have stored before. So 3 and then 2, so the maximum is 3. So in that way, we will find the left array. Similarly, we will find the right array. So for I equal to n minus 2 to 0. Okay, so the right I would be max of right I minus 1 and array of I. Okay, so here will be decreasing the value, right? I would be minus minus, here I would be plus plus. Okay, so here similarly we will have the right value. Okay, so the left value and the right value are computed now. Now we will traverse the whole array. We will have a value as int answer. Okay, so we will traverse the whole array now for I equal to 0 to n minus 1. And here our value answer would be answer plus equal to minimum, what we have discussed, minimum of left of I minus right of I minus array of I, and then we will return the answer. Fine. So what is the time complexity here? Order of n we have already discussed, but what is the space complexity? Earlier we were not using any array, right? Any extra data structure, but here we have taken 2 extra data arrays. So the space complexity would be order of n. Time complexity is order of n, but the space complexity is order of n. So we can actually also solve this problem using 2-pointer technique, and that will help us to solve the problem in the order of 1 space complexity. But if you give this answer to the interviewer when you solve this using time complexity of order of n, he'll be mostly satisfied. Okay, so the link to the question has been given in the description. Please try to solve it yourself and then come to my code walkthrough section. Here is the code walkthrough section. So you can see the examples over here, and we have already discussed this. So we have taken the left array and the right array. We are pre-computing the values here, and then once we have pre-computed it, we are using this formula to get the resultant value, and we are returning the result. So let's run this. Both the test cases are accepted. Let's submit this. So it's accepted. So the time complexity as discussed is order of n. And yeah, let me know how was the explanation, and see you in the next video. I'll be explaining the 24th question. Jai Jinendra.